Bart Kraakman is Associate Professor at Jacobs, a global engineering and solutions provider, and has over 25 years' experience in the odor industry. He has a master's degree in molecular science and is co-author of multiple scientific papers and book chapters on volatile gas emission and odor control-related topics. He is also a guest lecturer at several universities and is a professional engineer who lived in Europe, Asia Pacific, and North America, and worked on multiple successful projects for governmental agencies, industrial clients, and many small and large water corporations. His interests are related to sustainable design and applications of air quality treatment processes, and currently lives in the United Kingdom. So thank you very much and welcome.
Thank you. The standard that we just discussed is really, really valuable, but as we know, there are with odors different flavors, different parameters, and one of them is persistency, which I would like to discuss. This work was supposed to be presented by Professor Safet from the University of California. Due to travel restrictions, COVID, he was not able to be here, unfortunately, and he sent his regards. I happen to be a part of this project, and I was given the honor here to present his main efforts. I'd like to acknowledge Gloria Bien, Peter Yang, as well as Scott Cowden for this effort, for this work. This is a project that was focused around a facility that is a dry anaerobic digestion facility. It is based in California, a very large facility, actually the largest of its kind in the world. It processes, it produces clean energy in the form of biogas and engines, and through engines, mainly because organic waste is collected from commercial industries like food producers, big restaurants, supermarkets, and is treated in this facility, which is totally covered. They take the material in, they sort it, take out the plastics, put it then in digesters, take out as much as energy as they can get, take it out, put it in a composting tunnel where they dry it, partially stabilize it, take it out again, and bring it to another composting facility where it's further stabilized. This facility, as you imagine, is smelly and has been a problem over many years. The main objective here of this study was to identify the odor character and the intensity of the odors. We know it was strong, the odor concentration was well known, but we wanted to know a bit more about especially how these odors travel from the facility into the community. And there were a couple of sources, not only the building itself, but also the biofilters that treat the indoor air, as well as a couple of other odor control facilities around this place, mostly around leachate that was stored. This is the facility, and the methods that we used is the Opm method. This is developed by Professor Safet over the years, and the usefulness of the Opm method lies in the fact that our human nose is for most important odorants, is many degrees more sensitive than standard chemical compound identification analytical methodologies. And second, that the persistency of odors can differ from each other. And therefore quantifying the odor intensity as it travels from from the facility into the community, quantifying the odor intensity reduction with the dilution, and characterizing the main dominant types of odor can help understand what type of odor compounds are most critical for either ongoing monitoring or for developing odor control strategies. So the odor profile method basically takes it back to a lab where a trained panelist, at least 4 of them, characterize the smell and the intensity. Secondly, it uses an olfactometer to dilute that sample and see how persistent that odor is, how the intensity decreases over time. And this is important because the odorants, the individual odor compounds, actually have a different persistency. And I would like to, it's also called the peeling of the onion. Some dominant odors near the facility may disappear, and other compounds become more noticeable as they travel in the community. I like to compare it with noise or sound or music. If there would be a marching band here now in this building and comes by here, we would hear the flutes, the trumpets, the trombones, the snare drums, saxophones, the bass drums. But as this music corps travels further away, some of these music instruments are not so much noticeable anymore until they are outside and you maybe only hear the bass drum. Doom, doom, doom. Odors are similar. And so this is important to understand. Where do you need to focus on? Often we focus on the highest concentrations at the source, but actually it's what is about is what is causing the odor in the community. This is illustrated by, so the second method uses the Weber-Fetcher law that characterizes the relation between the intensity and the concentration as you dilute it. And for each odorant, this relation is kind of different, as is with music or more noise frequencies. This is illustrated here. This is work done by St. Croix as well as the lab of Professor Safet, where very highly odorous compounds are taken and are measured at different concentration, different dilutions here on the x-axis. Remember, here is a log scale, so every step is 10 times. And this is the intensity from a scale from 0 to 12. 1 is the typical odor detection threshold. Now, as you can see, some have a different slope than others. For example, here H2S. From a intensity from 8 till 1, it takes about 1.3 log steps, which is about 25 dilutions. If we look at this odorant, which is a musty odor, we need about 3.5 log steps, which is about 100 times more. And so this becomes relevant if we want to know what is really causing the odors problems in the community. And so that has been used here for this facility. Samples has been taken upwind. In this case, it was musty, a little bit, not very odorous. Remember, this is on a scale from 0 to 12. Downwind of the facility, these were the typical characterizations and the odor intensity. Then indoor the facility, very strong, as well as the biofilter. That emits most of the airflow treated. This is how this is projected. So typically take a bag, bring it to the lab, and you sniff. And what is the main character? This was from upstream, so it was kind of musty. as soon as you put it in the olfactometer, you have different conditions. You have the 20 liters per minute and all the right conditions around it, and you dilute that, and you get a nice curve. In this case, it was all musty. If we go to the downstream facility, it's a little bit different. Most prominent odors here were the rancid, as well as an undertone with sweet, and that after certain dilutions changes here into a musty odor. This is indoor from the facility, very, very strong, high intensity, kind of similar, rancid and sweet as it is reduced, and also the musty odors when it's significantly diluted. The biofilter here has this characteristic, mostly fecal, still very strong. This is an intensity of 5.5, and so this still could cause serious nuisance in the community. But if we compare downwind, which if you stand there, you really can't, if you're not trained, recognize where is this odor really coming from. But by looking at these profiles, it was pretty clear that the odors downwind were mostly contributed to the indoor odors. They were mostly related to that, and not so much to the biofilter. The reason for that is that inside it's very strong, as you can see, odors here. The facility needs to bring in material out, so it has doors that frequently has to be open. As we all know, common practice is then to leave them open. Very humid, very warm. All the odors tend to rise to the roof. There were serious corrosion issues there with leakages, and it was pretty clear that that building was under-ventilated and leaking seriously. So this is an illustration that the Opm method with the persistency curves can help understand which odors are dominant at the source and which odors become dominant when it travels in the community. This could be important not only for taking measures, but also inspectors. If they come to the scene where the odor complaint is and they're going to look for the facility, they might smell something completely different. And in this case, it also helped to identify the major odor source causing the odors. As I mentioned, upwind, not so much. The biofilter could still cause a nuisance, but the major here odor source was the indoor air from this facility that was emitted. And with that, I open the floor for questions. Thank you.
Thank you very much. Do we have any questions from the audience? Carlos? Yeah? Yeah, I don't see. Yeah, there is one. Well, you can start and then we. Okay.
Thank you very much for your speech. My congratulations to give such a different opinion, such a different view to the source, indoor, and to the nuisance. And relevant is the nuisance, but we want to find the way to reduce the nuisance. But it's good to have this work.
Thank you. It relates to the questions earlier this morning about the importance of hydronic tone, or do we need to have different legislations for different industries? Because, you know, 10 odor units from a facility like this is completely different than 10 odor units from a bakery, and we all know that. And so we have to find methods to dig sometimes a bit deeper.
Just a question to the biofilter. I don't know if I get it right. How do you describe the odor emitted from the biofilter? Was it musty? And I saw also fecal and something else. There was a fecal odor coming out of the biofilter?
Yes. So this is, I didn't present all the odor concentrations and also individual chemical compound analysis. But this was a very strong odor to be treated from in this biofilter. And this biofilter, although it seems to be operating well, it was reasonably well maintained, it reduced the odors significantly, but just not good enough. And from these kind of facilities, you have a lot of ammonia, and there was an ammonia scrubber up front here, took out most of it, but not all. And it is known that ammonia can build up in biofilters. It accumulates the salts, and that can kind of inhibit also the activity. So clearly the biofilter was doing its job, but it needs to do much better. That was, yeah. Is that answering your question? Or? Yeah. Okay.
Okay. Yep. One final question. Here.
Thank you for your interesting talk. I think that we have heard about 3 methods that actually complement each other, because we heard this morning about the interviews of hedonic tones of different livestock facilities. Then we've learned about the polarity approach. And then you're talking about the odor wheel. I mean, the 3 of them actually supposed to be complementary and give us the factors that we need for regulations, right?
Yeah, odor has different dimensions, and I think regulations currently with odor concentrations is very good. Like in the Netherlands, they distinguish different odor concentrations for different type of industries. I think that's a very good first step in the right direction. But sometimes if you want to solve the problem or you want to develop online monitoring, you just need to know a bit more, and this could help with that. Yeah. And all the others, like the hedonic tone, just describing the character, yeah, will help to build that full understanding. Does that answer your question? Okay.
Thank you very much.
Right. Thank you.